So, good morning, everyone. I'm just going to wait a minute to let everybody into the webinar, and then we'll get started. So, as you come in, we've got a lot to get through, so I will make a couple of introductions. So, first of all, welcome to this iMove webinar on end-of-queue worksite safety. I'm Ian Christensen. I'm the Managing Director of iMove, and I'm going to be your host for today. For those of you attending this webinar who drive a car, I want you to think about the time that you came around a corner and lo and behold, in front of you became a great traffic jam. And I'm sure if you're like me, you felt a degree of frustration. And if you're like my Leadfoot Larry nephew, you probably think, oh, Schweppes, I need to hit the anchors. So this is the end of queue problem, where motorists unexpectedly come across basically a traffic jam. And the challenge that road authorities have is how to reduce the risks of accidents occurring at the end of queue situation. So this is the subject of the work that has been undertaken by Deakin University for Transport for New South Wales, and we're very grateful to both organisations for the effort that they've put into this particularly challenging road safety problem. Before we get started, I'd just like to remind our participants to please put your questions in the Q&A, use the Q&A function. It's accessible at the bottom of your screen to ask questions. Please put the questions in as we go through, and we'll try to deal with as many of them as possible by the end of the session. We're going to have a Q&A session at the end of the webinar, and also I'm just informed that the report and the sort of story about this research project has just been published on the iMove website. So if you want to get a little bit more background, that's a place to go. So that's enough from me. I'd like now to introduce you to Alastair Lunn. Alastair is the Executive Director for Regional Road Network Maintenance in Transport for New South Wales. And first of all, to Alastair and to Transport for New South Wales, I want to acknowledge and thank you for raising this project and for the effort that you've put into this particular problem. It's relevant all around the nation, and we're very keen to find ways to reduce the risk and improve the safety, both of end of queue situations and for workers at road maintenance sites. So, Alastair, over to you.
Thanks, Ian. Thanks, everybody, for joining us today, and thank you for the opportunity to join everybody here in this session. Road maintenance and end of queue sites is something that's very close to our hearts. In Transport for New South Wales, I'm accountable for 21,000 kilometres of road network. Maintenance work around that network is ongoing every day, both within our own workforces, our contractors and our council partners. And end of queue accidents has become a real key risk for us to manage, both for our work sites and the staff on the work sites, but also for the travelling public who are interacting with our work sites. And we were really excited to be able to partner with Ashim and his team at Deakin University on this really important work. 2018, the first time I really became focused on end of queue accidents, we had a tragic accident on the Newell Highway, a two-lane, two-way regional highway in central New South Wales in a 110 kilometre zone, where a heavy vehicle entered our work site and impacted the end of queue on that highway, killing two members of the community, two young members of the community. But further to that as well, our staff were the first responders because it was a work site, and that led to a lot of psychosocial impact on our work staff as well. On that occasion, there was no impact within the work site, but we see plenty of occasions where end of queue crashes result in vehicles being pushed into our work site and having some significant near misses with particularly traffic control staff and workers on a work site. On that occasion in 2018, we had 2 kilometres worth of roadwork advanced signage plus VMS boards. The truck driver argued he didn't see any of that and impacted the end of queue, which was light vehicles at 92 kilometres an hour within a 40 zone. And you can imagine the death and destruction that led to. So end of queue accidents and reducing them in our workplace has been a key focus for Transport for New South Wales, and being able to partner with the academic brains of Ashim and his team has been a real step change for us, and the report that he has put together is really focused on how we reduce the frequency, the severity, and the occurrences of end of queue accidents across a road network as ours across Australia. So I really think that this report's a fantastic piece of work. We're really honoured to partner with Deakin, and it's really great that we were able to do some in-field real-time testing of the I commend the report to you. So I'll hand back to Ian to introduce Ashim and the team, but thank you.
Thank you, Alistair, for such a helpful backgrounder. And as I say before, this is a problem across the whole nation. So I acknowledge also that there are people from many jurisdictions present in the webinar audience. So to Ashim, Associate Professor Ashim Debnath is the Associate Head of School Research at Deakin, and Ashim has done, and his team have done an amazing piece of work, which you can access through the iMove website, to analyse what goes wrong at end of queue accidents and how that might be prevented. And they trialled, well, I'm going to say dozens of different strategies to reduce the likelihood and impact of end of queue accidents. But Ashim is the expert, so I'm going to invite you, Ashim, to share with us a little bit of the learnings that you derive from your quite extensive research into this question. Ashim.
Thanks, Ian, and good morning, everyone. And thanks for joining this webinar. And it was great to hear from both of you, Ian and Alistair, about your experience of end of queue situations at Roadworks. But what I want to highlight here to all of us here, that roadworks are our everyday events. We need roadworks to build new roads, but more importantly, to maintain our roads in a good condition. So we can't avoid roadworks, but what we have to do is to ensure that we manage safety in a way that our road workers have got a safe place to work, as well as our motorists are going through roadwork zones in a safe way. So from Safe Future Mobility Lab, I'm very proud to present about this webinar that we have undertaken in partnerships with iMove Australia, Transport for New South Wales. So thanks for this wonderful partnership to create this Australia's largest roadwork safety trial. And when I say largest, I'll provide some statistics later on that would give you some indication of the breadth and scope of this trial that we have undertaken. I want to put some special thank yous here to the steering committee members of this project. And it involved members, of course, from Transport for New South Wales, as well as from the transport authorities of other states and territories. Your input was really, really valuable throughout the project. Working group members, we had our weekly meetings to organize a massive effort in in coordinating all these site trials, data collections, and managing equipment and so on. Thank you for that. I moved him. It was a really, really pleasure, collaboration that we have had. It was a very productive collaboration. Thanks for that. And of course, my team at Deakin, including Sajani, Ross, Sadia, Amrit, Niu, Mahmoud, and Tarindu. Without you, we could not have done this. Now, first of all, what we will do in this webinar, I will provide a high-level overview about the project. We will talk briefly about the research methodology so that any future projects done could be benefited through the methodology of this project. And the results of this project are massive. It's impossible for me to capture those in a 1 hour webinar. I will try to provide some high-level overviews, and of course, the reports are published now, as Ian highlighted. Those reports have gotten more detailed results, and we will finish up with some recommendations that we derived from this project. So first of all, on the project overview, we wanted to reduce the frequency and or occurrence and the severity of injuries to people that are involved in end-of-queue crashes. And that includes, of course, motorists as well as road workers. And doing so, the overall plan is to improve the overall safety of staff and public at Roadworks. What are the outcomes that we wanted to look for from this project? We know that there are different types of temporary traffic control measures are used at Roadworks. And we often have some anecdotal understanding about their effectiveness based on how our experienced road workers felt whether this device worked or not. Sometimes we measure speed and compare the mean speed before and after. So there is a lot of anecdotal understanding evidence that we have had, but a proper evidence base for a range of temporary traffic control measures were missing. And I thank Transport for New South Wales for taking this important initiative to create that evidence base for a range of traffic control measures to obtain from this project. So that was our outcome, is to create an evidence base for a range of traffic control measures that are suitable for end-of-queue situations. I assume all of you know what is an end-of-queue situation, but just to make sure that we all are on the same page, at a roadwork site, we often have a lane closure, putting in one lane to be closed, so the traffic is stopped here, either using a traffic light or using other measures, and then queues form. And as vehicles come and join these queues, sometimes crashes happen at the end or incidents happen. So these are the end of queue situations that we are talking about. If the roadworks did not stop people are of course moving freely, then the occurrence of traffic queues are less in there. So whenever there is a traffic queue, we could potentially see end of queue collisions or near misses. The high level methodology, we had a 5-stage methodology in this project to look into. First of all, we had a project plan and where we created this project steering committee, including experts from a diverse range of areas, including traffic control, including roadworks, as well as those who are managing the MUTCD type manuals, for example, the TCOS manual in Transport for New South Wales. We then looked into identifying the end-of-queue treatments and best practices across the world. We, of course, had a comprehensive look into the literature. We looked into the different background materials available through our project steering committee locally here, as well as we ran an extensive consultation with industry stakeholders as well as international experts who have worked in this end-of-queue and roadwork safety space. So from this, we created a list of end-of-queue treatments that we wanted to test in the current project. Next step in stage 3, it came with actual testing of those selected end-of-queue treatments. We developed a study approach and we looked into trialing those on road. Once we collected those data, I will get into the details of what type of data in the next few slides. Then we started looking into how do we analyze those? Of course, there are traditional methods have used just looking into the mean speed or the 85th percentile speed or percent vehicle speeding with the control, without the control, and to get an understanding. There are some problems with this because it does not look into other factors that are available at a roadwork site. So we did look into a case control methodology where we compared before and after, but we did look into some robust statistical methods to truly identify the effect of a particular treatment by considering the range of time of day, traffic, and many other factors. And we looked into speed data analysis as well as the risk of end of queue crashes in our analysis. And eventually we did heaps of reports out of this. This final report is now published as was highlighted earlier. Now, why I call this Australia's largest roadwork safety trial? We looked into altogether 32 variations of end of queue treatments. We trialed all on road across 16 roadwork sites. More than 110 days of field data was collected and used in this evaluation. Every site we collected data for at least 5 locations. So for example, in this sample diagram here, you can see that one lane is closed and all these blue bars are referring to each speed measurement point. We also had video cameras on site on multiple locations with multiple cameras recording traffic movement coming and going towards the work zone. We altogether captured millions of drivers' data through this process across these 16 roadwork sites. We also talked to about 800 drivers as they were stopped at a traffic queue to know about their views of the different end of queue treatments. This is a list of all the 32 treatments. You would see 19 here because in some treatments we compared different variations of those. In some cases, we also combined some treatments. I don't want you to read this. This is available in the report, but it's just to show you the extent of the type of end of queue treatments that we looked into. Some were very basic, like different types of static signs. We looked into VMS, radar activated sign. We also looking into the UHF radio, temporary rumble strips, some high-end end of queue collision warning systems, as well as some newer generation, as well as some combinations. And we did all of this across 3 types of site: high speed, high volume, high speed, low volume, and low speed, high volume, so that these treatments were trialed across different types of work sites. This diagram, this figure here shows the different 13 trial sites that we had, and we also had 3 baseline sites to collect data from. These 13 sites, we had 5 high-speed high volume, 7 high-speed low volume, and 1 low-speed high volume. We wanted to have more in here, but depending on the site availability and suitability of the trial, we managed to get 1. So this shows across New South Wales of different types of roads that we looked into. Driver surveys, you might be thinking, how did we do this? So as drivers were stopped at a traffic light, researchers from our team actually approached them from the side with the help of traffic controllers spotting for them. And then we approached the drivers with some predefined questions, short questions with some predefined answers. So based on their verbal input, we inputted those in our iPads. So we asked them questions related to, did they agree with some statements about the end of queue treatments? What is their understanding about a particular end of queue treatment? Did they understand what this particular sign or message was actually trying to portray to them? What are their views of the future usage of these treatments? As well as some times we had multiple options to choose from. So we wanted to get drivers' views on which option they would have preference on. So we ran those driver surveys, we collected speed data and video data. So I will tell a bit more about the speed data analysis collection and the video data analysis and collection in this evaluation methodology. So we looked into speed using automatic traffic counters or the pneumatic tubes. These are called in many ways, right? So from these, we collected at least 5 points in the approach of a work site on one side, and we compared mean speed treatment minus control. We looked into 85th percentile speed. We looked into percent vehicle speeding because this is what typically is done in the literature. However, what we did a multivariate analysis of the speed data. This is where our contribution comes in, and I will tell a bit more about this Tobit regression in the next slide. What it does is that it looks into a heaps of factors other than that end of queue treatment. We also looked into near misses as happened on the approach to each roadwork. We recorded videos using the cameras that you saw earlier, and we compared time to collision distribution as well as other measures of near misses for this end of queue situations. And of course, driver surveys gave us a view of what drivers felt or what drivers understood, what drivers preferred about the end of queue treatments. So we looked into all these three aspects for every single end of queue treatment that we have evaluated in this project. So why we need to look at beyond mean speed and 85th percentile speed? So that's the speed distribution of any typical road. There's the speed limit. If we look at the left and the right, there's compliant, non-compliant. Primarily, our interest is on the right-hand side. So if we only look at the mean speed, from this distribution, we're only getting a single point. That's not telling much. So we model this using a Tobit regression framework where these compliant drivers were treated in a particular group and the non-compliant drivers were modeled in this Tobit model. What the beauty of this model is that it actually helps us to look after heaps of factors that just mean speed can't capture. And also, this Tobit regression model helps us to get two different estimates. One is the probability of speeding at a particular roadwork site. Second is that what is the magnitude of speeding? Or in other words, what is the amount of excess speed the drivers exhibited at a particular roadwork site? Just to show you the different types of factors that we considered, there are 5 to 6 speed measurement points, whether treatment was on site or not. That is the key variable that we considered. Time of day, if there is a platoon of vehicles. So if vehicles are moving in a platoon, of course, the speed of the platoon leader would be dominating the speed of would be setting the speed for the vehicles that are following. So we wanted to capture that in our analysis. We also looked at the type of vehicle that as a driver I have in front of me, and that would influence my speeding behavior as well. We also looked at traffic volume, proportion of heavy vehicles, proportion of vehicles that were speeding, as well as proportion of vehicles that were speeding by quite a bit of margin, so that we capture the whole traffic scenario in our modeling. So in this model, when we put together all of those variables and then this particular variable treatment on site, it gave us the true contribution of speed reduction of that particular treatment. Video data analysis, we looked into two particular measures, time to collision and deceleration rate to avoid a collision. I'll show you a visual here. Two vehicles moving 40 and 45 at a particular given time. If we let them continue at their current speed, they would collide at some point. And that time is called time to collision. Deceleration rate to avoid a collision, DRAC, is referring to at what rate the follower vehicle would need to decelerate to avoid a collision. And those recorded videos we processed using a automated image processing tool, which helped us to get the trajectories of every single vehicle. Our team looked into a manual validation process of these trajectories so that we could avoid issues in terms of false conflicts and so on. So we did all this to get an estimate of the collision risk using an extreme value theory analysis approach. Now, the fun bit comes. Results. Now, there are 32 treatments, 13 trial sites, how do we present the results in a nice way that can be captured in a short webinar. So this empty table here shows the structure of that results. So we looked into reduction in access speed, looked into reduction in probability of speeding. So these two key measures from the speed data analysis. And we did this, you know that there are 5 multiple points in a roadwork site. So we looked into 3 areas. One is advanced warning area before the treatment, in the advanced warning area after where the treatment was located, and one is in the transition zone going into the taper and the safety buffer area. We also looked into the impact on rear end crash risk. We looked into the driver views about the treatment's effectiveness, as well as drivers' views on the future use of this treatment. By considering all of those, these 32 treatments we have categorized into 4 categories. One that are most effective, moderately effective, limited to no effects, and then another group is called the treatment combinations. That's where we put 2 treatments together, and we wanted to see if they actually add any value, any additional benefits. So what I will do, I'll take you through these 4 groups one by one, of course, focusing more on most effective treatments so that we understand what those are. Just very quickly, so how did we consider this grouping? Of course, this, access speed, this value is different from speed. It's not mean speed, it's the speed above the posted speed limit. So if we are talking about 2 km reduction, so if the access speed was reduced by 2, it's not the speed, the mean speed. So this value has got more significance than mean speed. We used some categorization of this based on by looking at the speed distribution values. We also looked into the probability of speeding and categorized them into small, medium, large, or no significance, and so on. We had an inconclusive category because we had multiple sites, and if we saw that in one site it was positive, but for the same type of site it was negative in a different site, so it was inconclusive. Rear end crash risk, we looked into some categories as increased if both DRAC and TTC show consistent result. If both of them decreased, we put them into decrease, or if opposing results, it was inconclusive. Similar way, drivers' views, we had positive, negative, and mixed, depending on their views on the effectiveness of the treatment and future usage of the treatment, what they felt. So in the summary, first of all, for the most effective treatments, we have these treatments came from this 32 list. Don't worry about all this L, M, and V's. I will take you through this a bit later on. But for now on, what is E-series condition 2? It may mean nothing to you. So we have got some photos. The E-series treatments are from these arrows E-series devices, which has got a traffic light and a boom gate, and is called ESS. It's a BMS board that can actually show messages. But the beauty of this is that all 3 can be integrated and they can talk to each other. So we had 6 different conditions in our trial. In condition 1, we had this E-stop and E-cess only, and this line means they were talking to each other, they were interconnected. If the status of E-stop changes, it would show a message on E-cess accordingly. Condition 2, we had an additional E-cess, but it was not linked to those. So this will show standard message. It will not change depending on the condition of that red light or green light. In condition 3, we had 2 lights on each side of 1 light on each side of the road. Condition 4, we added the boom gate. Condition 5, we had all of these 3, so the 2 ESSs, 1 on each side, and all 3 were linked. There's 2 which are not linked to the others. And then condition 6 is only on one side, and we had 2 ESSs linked to the E-stop condition, and another ESS independent of this. So from here, we saw that condition 2, 3, and 5 were among the most effective treatments. I will elaborate a bit more onto the condition number 2 in the next few slides. But before that, what are the other most effective treatments we had? Temporary rumble strips are widely used, and we found those very useful in alerting drivers about an upcoming work zone, as well as reducing their speeds and looking into improving their attention. We had 4 conditions to test. In condition 1, we had 3 strips at 3-meter spacing each. Condition 2, we had 2 arrays of condition 1, so 3-meter spacing. Condition 3, where we had 3 strips at the same spacing, and here depending on the spacing is 9-meter for 60, 12-meter for 80. And condition 4 is a variable spacing. There's 5 of those. And these conditions were derived with input from Transport for New South Wales team by looking into the manufacturer's prescriptions, as well as what we have currently in the TCOS manual. Now from here, we found that the condition 2 were among the most effective treatments, where we had 2 arrays of 3 strips at 3-meter spacing. Other most effective treatments, and no surprises here, police presence always works, and we also found the same. We also looked into an innovative treatment called narrower lane width or gateway type treatment, where we used cones and bollards to narrow down the lane width so that as people approaching a work zone, the work zone is on the right-hand side, and they go through this gateway and what effects it may have. We also looked into this standard static sign with flashing lights on top. So that you can see one, there is another one on that was alternatively flashing. And there's one of our wonderful friends who helped a lot about the field data collection. So very proud to show him here. So the summary of all of those treatments, we had these treatments categorized as most effective. Let's look into E-series condition 2. In the advanced warning area, before treatment, the access speed reduction, probability of speeding reduction was large and very large. Same goes into after treatment. When it goes into the transition zone in the taper, it is lower. So moderate and large. Looked into the rear end collision risk, it decreased. Drivers were mostly positive about the effectiveness of the treatment. They also were positive about, they wanted to see this in future work sites. Similar way, if we look at police presence, for example, it had large and very large, large and very large, and continued to the taper and safety buffer area. But we found that the rear end crash risk, instead of decreasing, it actually increased. Drivers' views were mixed. Some did not like to see police on site. Some did not want to see them in future sites as well. Why it increased, it may seem counterintuitive, but the reason is that police was located at a particular point in the work site, and of course, they had their flashing lights on, and based on the visibility, some people may have reacted a bit harshly in terms of reducing their speed, which may have actually caused these near misses that were recorded using TTCs and DRSs. That is one of the reasons, and that's a phenomenon that we also observed for temporary rumble strips. It alerted people because people were positive about those, but we saw that the crash risk was increased. So it actually shows us that if we only look at speed to understand the effectiveness of a particular treatment, we may not be getting the full picture. So with that, I want to highlight a bit more about E-series condition 2 so that you get some understanding about what is in the report. Unfortunately, I can't go through every single of those, My heart wants to, but we don't have sufficient time to do that. The E-series condition 2, I'll show you some detailed results so that, as an example of the different treatments. So first of all, we looked into speed and speeding. This particular table here is the output of that Tobit regression model. We develop models for every speed measurement point. There are 5 of those. We looked into this key variable where the treatment was on site. If it is yes, negative means that it was a reduction. The stars means that it was a statistically significant result. And we had multiple sites, time of day, platoon, and those other variables that I talked to you about. From here, these values were calibrated based on by considering the effects of other variables. So if we only look at treatment, we don't consider any of this, then the values that we are getting would be different because these are not the true effects of the treatment. But if we consider all these variables, we get the true effect. So that's what we did. From here, what we did for the different speed measurement points, there are 5 for this particular treatment. Change in access speed. So without and with. So negative means it was a reduction. Same goes in the probability of speeding. Usually this treatment was around this SMP3, speed measurement point 3. And you can see that closer to it, the reductions were more. But people started noticing those early in the advanced warning area. So they reduced their speed a little bit. But when they came closer to that E-series treatment, it was significant. And of course, the reduction reduced as people go into the work zone. Same phenomena was observed for probability of speeding. So for every single treatment, we had charts like this, based on which we get this low, large, very large, medium, or whatever classification that you have seen in the previous slide. Probability of exceeding this DRSC threshold and exceeding the TTC threshold, we compared those in terms of the treatment and baseline. So if the values are lower, that means that those were they were reducing the crash risk. I'll show you a little bit more on this. For example, for TTC, we had a distribution of the baseline data and the treatment. So when the E-series condition 2 was on site. And given that this time to collision, you have 10 seconds, 20 seconds to avoid a collision, you've got plenty of time. So we are usually interested in the lower end. So it's a zoomed version of this on the right, showing from 0 to 5 seconds. And usually in the literature, we use 1 second as the threshold. So things that are on the left side of it, we compared in order to get this estimate of exceeding that threshold. For DRSC, we use 3.4 meter per second square. So of course here is not on the left side, is on the right side, things that are higher. So I needed to brake harder I needed to decelerate harder to avoid a collision. So we looked into that and then again compared the treatment and baseline. Driver survey results, we asked them multiple questions. So for example, for this particular treatment, the question was, did you notice the 2 signs showing your speed? Most of them noticed. There is one, some only noticed 1, not the 2. We asked them, did that help them to be alert of the stop traffic ahead? Mostly the rest was positive. Some were unsure. Some did not find. We asked, do the signs help drivers to avoid an end of collision? Most people agreed. Do they want to see this in future? Most people agreed. Then all of these questions we divided into different categories of the demographics. For example, young, mid-age drivers, old-age drivers. Of course, we did not ask the drivers how old they are. This is our interpretation, and I think our team did okay in guessing people's age. Gender and vehicle type we also considered. So just to show you that we also looked into some breakdown of the driver survey results. And similar results we did for all treatments that we considered. Okay, now I want to move on to the next group of treatments, which is the moderately effective treatments. And as you can see here, that large and very large, those things are less prevalent here. We had a couple of E-series conditions, some static signs, and some other treatments. I'll show you the photos so that we understand what those things are. So E-series condition 4 and 6 you saw earlier, where we had this addition of boom gate, and E-series 6 where these are all on one side and there are 3 ESSs on that road. TPRS condition 1, where we only had 3 strips. So the most effective one had 3 strips in 2 arrays, but here is only 1. So having 1 gives us moderately effective results. Having 2 arrays give us most effective results, better results. We considered this configuration of static sign, the Q, symbolic Q as prepared to stop, and this was selected through a focus group discussion with some road users and industry experts by looking into multiple combinations, and we found that to be moderately effective. So just a simple static sign can help people reduce their speed and be aware of work sites. There is a series of sites that we used in sequence, starting with this, then reduce speed, and then this symbolic Q ahead sign. This was also moderately effective. Turn on hazard lights when stopped. So this particular sign was used on some roads to let drivers know that when they come to stop, they would turn on their hazard lights so that the vehicles that are following them, they are aware of this. In some roads, even without this sign, we found people were doing this because it was foggy, and they said that we usually do this in this area. And for the sites that we trialed this treatment, we found moderately effective results. So that was a good thing. We also compared VMS in 2 conditions. One is a color VMS versus a monochrome one. The results for the color VMS was, of course, more positive in terms of reducing end of queue risk and driver speed. We looked into 2 configurations of UHF radios, and I must say that evaluation of these were restricted to heavy vehicle drivers only. And the 2 combinations were manual and automatic. So predefined messages where pre-recorded messages were relayed at a regular interval in the automatic version of this. In the manual version, a person sitting at that work site were broadcasting those messages at a regular interval. And we found that the manual one had more better effect than the automatic one. And of course, we also saw some unwanted consequences in terms of drivers getting into a conversation or trying to say things to the person who were on radio to broadcast those messages. So there are some unfortunate consequences as well in there, just to keep in mind. So in summary, for the moderately effective treatments, and I will not go into the detailed results of those because these are in the report, but E-series conditions had another 2 versions as moderately effective. These 2 static signs that you saw, they also showed some small and medium effects. So it shows that appropriate use of the static signs itself can actually help us get some reduction in speed. And it was inconclusive for rear end crash risk. But drivers were positive about the 3 sign combinations. For the 2 sign on side by side, that one we did not have mixed views from drivers. Temporary portable rumble strip condition 1, it has small reductions here. Similar to the condition 2, the crash risk increased, but the drivers were positive about those. They felt that it alerted them about the upcoming work zone. Hazard light on stop, it showed some really good effect up front. Then it becomes small and become inconclusive in the taper area. There is an increase of crash risk, but drivers were positive about this. We also looked at how many drivers were actually turning on their hazard lights as they were coming to a stop. Not a large proportion of drivers were doing this, but of course, in a wide use of this sign across multiple roadwork sites for a longer time period can actually help improve that compliance level. And we had two other groups, so I will not go into the details of those so that we have time for some Q&As. We had some other individually trial treatments like the BMS in monochrome, radar activated speed sign. We had an advance warning vehicle put in the advance warning area with a static sign on it, with a VMS on it, is to alert drivers of the upcoming work zone. We also had rumble strips, the two conditions where we had variable spacing or longer spacing than 3 meter. UHF automatic, we used the zigzag lines are type of the lines that you saw on the road as you approach a pedestrian crossing, for example. Barmac was an high-end end of queue warning system typically used in the US. We trialed those, and our effects unfortunately was not as good as it was found in the US. And E-series condition 1 had some treatments here, but we have seen the other E-series conditions were producing really good results. We wanted to see if adding multiple treatments on one site can actually have additional benefits. So for example, this narrow lane width, which was an most effective treatment, we connected the BMS color with it, but the additional benefit did not outperform narrow lane width alone. Same goes zigzag line with that. We did not have additional benefits. We did Barmac, police, E-series conditions with rumble strips. And our conclusions here is that having multiple things not necessarily lead to improved results or additional benefits on the sites. Now, couple more slides, and then we will get into questions. So in some further summary of the results, I want to let you know that in the report, we would see some results put into different areas of work sites. For example, in the advance warning area around the first speed reduction sign, there were some treatments that were producing large and very large reductions in speed, of course. In the advance warning area around the second speed reduction sign, and of course ahead of the taper, some other treatments were showing large and very large reductions. In the transition zone around the taper, these two showed large and very large. So in case you are interested in trying to find a localized speed reduction treatment. When we looked into the crash risk, there are some that actually showed significant reduction in crash risk. Some, of course, had a bit of increase, but it had benefits in terms of reducing speed. Driver's views, mostly these are positive for most of the treatments. Some treatments, there is mixed views like this static sign number 1, advance warning vehicle having a static sign or rumble strips or the police presence. So there are some concerns from people. So what are the recommendations from all these things, all this work? So first one is that we recommend that those treatments that are identified as most effective and moderately effective are to be used, to be considered to be used on roadwork sites to manage end of queue crash risk. We also recommend that for before using those treatments, site-specific risk assessment should be done so that the site conditions, traffic guidance schemes, and more importantly, the cost implications would need to be considered so that those are done prior to the using those treatments. We recommend to Transport for New South Wales and the wider transport industry to extend the trials that was done in this current project. So for example, this methodology could be used to apply the trials to more sites and for longer time frames, because we only looked at a short time frame assessment. Should look into the long-term impacts. For example, the trials that we did were for short term, about a week or so. So the novelty effect of those treatments may not have been properly looked into. If we had the opportunity to trial this in a long term in future projects where we could look into the novelty effects of those treatments as well. And more importantly, the heavy vehicle perspectives would need to be looked into a bit more details, because in the current project, we looked into that to some extent, but there is more could be done. So these are some of the recommendations to be considered beyond this project. And with that, I thank all of you for your attention, and over to you, Ian.
Thank you, Hashim. That's a spectacular piece of research that you and your team have undertaken. And I'm particularly impressed that you've been able to so clearly discriminate between effective treatments and moderately effective treatments and ineffective treatments. I think that provides a very strong direction for road managers to exploit to improve the safety of their work zones. So we have a lot of questions, and I invite participants to this webinar to keep adding to the list through the Q&A function. Those that we don't get to in this last few minutes of the webinar, we will endeavour to answer, shall we say, offline. But for now, so I'm going to start actually with Alistair. Given the sort of clear evidence that Hashim has been able to demonstrate that some treatments work quite a lot better than others, is that sufficient guidance for you and for Transport for New South Wales to inform how you proceed from here?
Yeah, thanks. No, thanks, Ian. And you're right. There's been some really clear evidence that a lot of these trials do make a difference, and Hashim's work's been fantastic in that area. We're continuing to trial these treatments, but we're also working closely in New South Wales. We have the traffic controls at work sites manual, so we're looking at how we incorporate these treatments into our traffic control at work sites manual, so that we can write them into contracts, we can utilise them more extensively across our projects. But I think the evidence is clear that stuff like the E-Series conditions and also, UHF conversations with truck drivers all make a difference. We also do actively work with the New South Wales Police to monitor our sites, because those red and blue lights do make a difference to us all when we're driving around as well. But I think the permanent setups that have been highlighted are things we need to really bake into our traffic control at work sites contracts, and therefore we can, and also our manual. Yeah, we're committed to it.
Thanks, Alistair. Perhaps to Alistair and Hashim, it's interesting that, and perhaps not surprising, that police presence had such a strong effect on driver behaviour compared to the various alternative technologies, including signage, that didn't. And I wonder does that reflect a difference in the effect of fear of being caught, compared to being informed about how the drivers could make better driving decisions? I mean, it feels to me like there are two psychologies being at play here.
It's a psychological challenge we face with the road toll as well. People who speed all think, well, they'll be fine at speeding because it won't happen to them, and it's the same in this case. So people believe that those accidents won't impact them; they're not part of the problem. Whereas police and a fine and a potential loss of license are a real strong deterrent. What we need to do is continue through our campaigns to highlight that the flow-on impact of not obeying traffic control guidance at a work site can have on both them, community, and their families, and also on the workers that are working in the site. So that's another campaign that we are running in parallel. But it is a psychological problem, an issue that we have to get into people's mindset, and it's a real challenge. But I'll hand to Hashim, who's probably got more to answer on the technical side.
Certainly, I think the chance of being caught, I think that is at a personal level. The care for road safety of the rider, it is also at personal level. But I think, I mean, it's there is evidence in the literature to say that perhaps for the first one, there is more people on this boat than the care for safety. So I think the chance of being caught is can play a significant role, and we have seen that in the visible police presence versus not visible and how it influences people's driving behavior. So that certainly plays a big role. But I think you're right, Ian, that I guess understand people having broader understanding about the risk on our roads, having empathy for road workers who are actually working on the side of the road, can have a broader impact on people's driving behavior, changing people's driving behavior, if we can find a good way to do that.
Thanks. So one of the questions in the Q&A relates to the potential overuse of road warning signage or abandonment of warning signs that were not collected at the end of the roadworks. And the proposition is that does that lead to a certain disregard by motorists? And I'm wondering, Ashim, in your interviews with drivers, where you found that some of the static signage was not so effective, do you have a view, or were you able to discern why the drivers were dismissive of some treatments and yet not attentive to others?
Of course, many things happen at a roadwork site. So in the background, there is a lot of activities are happening. So if the signs are not visible to drivers, then drivers are would be finding it difficult to actually notice all of those. From compliance reasons, I do understand that the traffic control companies would need to have a set number of signs of various types on roads, but having more is not necessarily producing a better outcome. I think having key signs on road that people would notice and would have respect for is perhaps the good way to do. But now that thing about that removing a sign as the work is on pause for 2 hours or half an hour, that risk of putting that sign on the road and removing it is a safety hazard for that particular road worker. So I think there should be a safer system to manage that risk, that the retrieval of signs and installation of signs is done in a way that actually not discouraging people to just let the sign on the side of the road for half an hour or 2 hours. So it is certainly a concern for many drivers who would love to see that no road work happening, road workers are not on site, things are back to normal speed limit. It also shows that the misunderstanding perhaps some drivers would have. So I'll just provide this example to explain this. A road is being maintained. It is not to the normal driving condition. If the normal speed limit is 100, it can't have 100 when things are happening on the side, even if road workers are not visible. So the road is not suitable to have the pre-roadwork speed limit at that time. So it is a message that perhaps we need to communicate with our drivers more effectively, so that that respect for roadwork signs and speed limits are more across the driving community. Now, to answer your specific question, did drivers say anything? Yes, we had some really interesting chats, and I recall one of my team member reported to me that a driver was very enthusiastic. They actually came off their truck to have a chat on the side of the road, which we discourage them to do. So yes, there are some drivers who are very, very enthusiastic in terms of sharing their views about whether signs should be on road after road work finishes or workers are not visible.
And perhaps a sort of slight follow on from that, and this will probably be the last one. Ashim, did the drivers know in advance that they were participating in a research project, or when did it become apparent to them, and does that affect the results?
So having these pneumatic tubes, the automatic traffic controllers, these are common across our roads, and we do not believe that this would influence the result. Those cameras were, of course, noticed by some people, and those cameras are also used across our road network. And those cameras were sort of closer to the taper area, and we have measured their speed in their previous areas as previous to that as well. When we approach drivers to talk to them in the survey, of course, we had to tell them that these are they are being interviewed for a particular research study, and we had our university. So we did not represent the roadwork company or Transport for New South Wales. We are doing this for from Deakin University. So we do believe that drivers would be answering those questions with an independent view.
That's fantastic. So we are at time, but I'm just going to give Alistair a last opportunity for a comment, if you wish.
First of all, just again like to thank Asham and the team for the collaboration they did with Transport, and also the Transport for New South Wales workers who assisted in our contractors on sites. I think the point Asham was making earlier about signage, more signs isn't always the answer, and we need to be better at removing our signs when we're not there for long periods. I agree with Asham. You can't take them down for an afternoon tea break or a lunch, but certainly for weekends or for longer periods, because I think we need to really encourage. But this is a really great report. We'll continue to work in New South Wales as we will across Australia in making our work site safer for both road users and road workers. So thanks for the opportunity.
Super. Thanks, Alistair. We will endeavour to answer all the questions that we didn't get a chance to answer right now. And I invite you all to reach the project report that's available through the iMove website at the location that's in the chat function, actually, if you wish to pursue it, or you can just search the iMove website. Thank you all very much for your participation. Thank you, Alistair. Thank you, Ashim. It's a great piece of work, and I look forward to seeing the results becoming implemented across the nation. Thank you both, and thank you, everybody.
Thank you.